Good morning, students. Welcome all of you in the ninth lecture of chapter number 8. Yesterday we started exercise 8.2 and we discussed basic of this exercise. Basic was midpoint theorem and converse of midpoint theorem. So yesterday we discussed question first and sixth. Their midpoint theorem was used. Now we will discuss the question number second. So let us read the statement question number second. ABCD is a rhombus and PQRS are the midpoint of side AB, BC, CD and DA respectively. So this is ABCD is rhombus. Here PQRS are midpoints of different sides respectively. Then show that quadrilateral PQRS is a rectangle. So to show that this PQRS is a rectangle. So here is construction that join AC and BD. Now starting of question first, second, third and sixth. These four question starting is same. So we will take triangle ACD. S is midpoint of AD, R is midpoint of CD. These two lines. Then this line is joining two midpoints. So we can say by using midpoint theorem, SR parallel to AC, SR half of AC. Let equation number first. Now we will take the triangle ACB. P is midpoint of AB. Q is midpoint of BC. Then by using midpoint theorem, this PQ is parallel to AC and PQ half of AC. So first and second equation, here AC is common, here half AC is common. So from first and second we can say AC will cancel, SR parallel to PQ and SR equal to PQ. Now if we see here, then SR and PQ are opposite sides of quadrilateral PQRS. So now one pair of opposite side of quadrilateral PQRS is equal and parallel. So PQRS is a parallelogram. So from solution, starting of solution to this point, this question first, second, third and sixth steps are same. Here in question number first also we write all these steps. Sixth also we write all these steps. In second also we are writing all these steps, and after this when we discuss question third, again we will write these same step up to here. Now so we prove PQRS parallelogram, but actually we want to prove it is a rectangle. So if we prove that out of these four angles any one angle is 90, then we can say it is a rectangle. So SR and AC are parallel from here. So SE is part of SR, OF is part of AC, so we can say SE and OF are also parallel if SR and AC are parallel. Similarly, we can say SF and OE also parallel. So in this small quadrilateral OESF, both pair of opposite sides are parallel. So both pairs of opposite side of quadrilateral OESF are parallel. So OESF is a parallelogram. Now it is rhombus. So angle 1 will be 90 because diagonals of rhombus are perpendicular to each other. But this small OESF we prove parallelogram. Then angle 1 will be equal to angle 2 because opposite angle of parallelogram are equal. Angle 1 is 90, so 2 is also 90. So when this angle is 90, it means one angle of parallelogram PQRS is of 90 degree. So PQRS is a rectangle. So if we prove any angle of a parallelogram is 90, we can say it is a rectangle. So up to here steps are same. These are different steps. So from this step to this step we will discuss again in question number third also. So now third question. Here ABCD is a rectangle and PQRS are midpoint of side AB, BC, CD and DA respectively. So here ABCD is rectangle. So we will draw figure of rectangle. PQRS are again midpoints of different side. So this is given. Here we want to prove PQRS is a rhombus. So PQRS is a rhombus. So in second question rhombus was given, we proved rectangle. In third question rectangle is given and we want to prove rhombus. So solution. So starting is same, just like question 1, 2, 3 and question 6. Starting is same. First we take triangle ACD. S is midpoint of AD, R is midpoint of CD. So SR will be parallel to AC and half of AC. So I am directly writing this step, but you have to write all the steps. You don't leave any step in between. I just left some step here because already I write this step in first, sixth and second question. You have to write all steps. Then we take triangle ACB. P is midpoint of AB, Q is midpoint of BC, so PQ parallel to AC and half of AC. Again, I am don't writing here some steps, so you have to write all the steps. So again, I am skipping some steps here. So directly I am writing PQRS is a parallelogram. So from triangle ACD, we are just moving and we are reaching as PQRS is a parallelogram. All steps are same. Again, I am revising in first, second, third, and sixth question. So you have to know, you have to not skip any step in between. You have to write all the steps. Now these are extra step in this question. Now we will take triangle ABD. So P is midpoint of AB, S is midpoint of AD. Then by using midpoint theorem, we can say this PS is parallel to BD and half of BD. So PS half of BD will be equal to AC because diagonals of rectangle are equal. ABCD is rectangle. So AC and BD are equal. So in place of BD, we can write AC. Now SR half of AC, from here I am writing. So proved above. So in these two, half AC means right side is same. It means this will cancel. PS equal to SR. So if you check here, PS and SR, this is the adjacent sides of the parallelogram. So now one pair of adjacent sides of parallelogram PQRS are equal. So PQRS is a rhombus. So in this parallelogram, if we prove any one angle is 90, we can say it is a rectangle, as we done in question second. And if we prove any pair of adjacent side is equal, then we can say this PQRS parallelogram is actually a rhombus. So these four questions, first, second, third, and sixth, are based upon the same concept. So tomorrow we will discuss remaining question of this exercise.